Hi there, this is Mr. Baker. This is going to be the first video for the Algebra for the College Bound in the fall 2020. Anytime I refer to the book or problems or examples or anything like that, that's going to be in the OpenStax college algebra book. I think it's my intention to, as I'm doing these videos for at least our virtual quarantine time, that there'll be parts where I ask you to use the book to fill things out on your own. So I'll let you know what page you should be looking on and stuff like that. But this first video, I'm going to go ahead and just walk you through the whole notes for this section. But just letting you know things will change a little bit, and there will be problems you have to answer as you go through the videos and stuff like that too. Just to try to make things a little bit more interactive, and the point of having you guys try to read the book and do some of the notes on your own is just trying a different type of learning, that reading rather than watching. So it's just a little different, and something that we all need to be able to do as we move further into our educational career here. So I want to go ahead and get started and not waste too much time just talking. Watching videos isn't always the most fun. So this first chapter in this book is really a lot of review for just skills, and so there's not a lot of necessarily cohesion with it. Just like, okay, hey, let's work on this, make sure we can do these things. Let's work on this, let's make sure we can do these things. This first section especially should be really simple, just work on number systems and order of operations and things like that. So something you guys should have a lot of experience with. Just need to get our brains going again. So first thing we're looking at is number systems, and so we have different types of numbers, sets of numbers. So we have the natural numbers, which are counting numbers, 1, 2, 3, 4, 5, 6, 7. Then we add on the whole numbers, or let me switch to the set of whole numbers, which is just add 0 into that set. So it's 0, 1, 2, 3, 4, 5, 6. Then we move on to integers, which then adds in all the negatives, and then we move into rational, which adds in all the ratios or fractions. And then if you notice here with this notation with the Q with a little apostrophe on it, what we would call that would be Q prime. That would be the irrational numbers, so all the numbers that can't be written as fractions, so like pi or square root of 2, numbers that are not, square roots that are not perfect squares, so like square root of 10 or square root of 33 or something like that. Those are all irrational numbers. So first thing we do is just going to classify, look at a number and classify what set it belongs to. So looking at the square root of 36, since that is a number we know the value of as far as it is a perfect square, so that equals 6. And 6 is a natural number, and it's also a whole number, it's also an integer, and it's also a rational number. So it fits into all of those sets. 8/3 is a fraction, so that means it's not a whole number, it's not a natural number, it's not an integer, so it's just a rational number. The square root of 73, that's not a perfect square, so that would be an irrational number. So I use Q prime as the symbol for that. -5, it's not natural, it's not whole, it is an integer, and all integers are also rational. And then I have this last number here. So looking at, could we write this number as a fraction? So what we'd have to be able to do there is notice that there would have to be a repeating pattern. For a decimal to be able to written as a fraction, it has to be a repeating pattern. So if I look at it, it's 3, 2, 1, 2, and then 1, 1, 2, 1, 1, 1, 2. So there is a pattern, but it's not a repeating pattern because the number of ones is changing. So this is actually an irrational number. Remember, numbers cannot be rational and irrational. They can only be one or the other. And irrational numbers are none of the other sets. They are out there on their own. So that's classifying numbers, just kind of knowing what you're working with. Definitely will be something that you need to be aware of. Is like when we're working on problems later, is like, okay, what type of answers make sense? Like, okay, I should be getting a rational number for this, or I should be getting an integer for this, and things like that. Order of operations, of course, super important when you're working on math, is knowing what order to do things in. So You should know about PEMDAS for a long time. Parentheses, exponents, multiplication, division, addition, subtraction, and then when you're doing those multiplication and division steps, that you're doing that in order from left to right, and when you're doing those addition, subtraction steps, you're doing that in order from left to right. Another way of saying parentheses is grouping symbols, and so you'll see that here. So anything that's grouping, and so what a grouping can be is anything that's kind of put together in one place, and you'll notice stuff like the things under the radical, the numbers under the radical here are grouped because they're all under the radical, and these numbers up here on the numerator are also grouped because they're all being divided by 7. So, but where we start is by looking for the simplest of the grouping, which would be the stuff that's under the radical, since there's nothing else to do there. So we just need to figure out what 25 minus 9 is, and everything else would stay put. Of course, when you're doing stuff like this, you can do some things at the same time, but I'm going to take it slow here, and then we want to simplify the radical. So the square root of 16 is 4, so that would just give me 5 squared minus 4 over 7 plus 2 times 4. Now I want to simplify the exponent. So 5 squared is 25. And then now I need to deal with the rest of the grouping here, since there's still some numbers that are need to be simplified in that regard. So 25 minus 4 is 21. And then now we've done all the exponents, we've done all the groupings, we're on that division multiplication step, and so we want to go from left to right, and so the 21 divided by 7 is on the left, so that'd be the first thing we simplify. Then the 2 times 4 is on the right, so it's the second thing we simplify. And of course 3 plus 8 is 11, so there's our final value is 11. Looking at the properties of numbers, so we're kind of the rules, the commutative property says that we can switch the order when we're talking about addition. So if I had something like 7 plus 40 plus 3, if I really wanted to, I could say, well, what that allows me to do is just move things around. I can add those in any order I want. Like, oh yeah, adding 7 and 3 is easy, then I should start there. The commutative property of multiplication kind of says the same thing. If I had like a half times 7 times 8, well, I'd rather take a half times 8 first, since that's easier to do. So we're allowed to move things around. The associative property deals with grouping. So same thing with with addition. So if I had something like 11 plus 12 plus 8, I could rewrite that and say, oh, that's the same thing as 12 plus 8. Well, I could say it's 11 plus 12 plus 8. So I could add those together first. And similar idea with multiplication. If I had like 0.5 times 25 times 4, I could say, oh, I could just rewrite that as 0.5 times 4 times 25. So I could change the way things are grouped in order to make things easier. Distributive property. If I had something like 1/4 times 24 minus 8, one way I can deal with that is to say, well, that's equal to 1/4 times 24 minus 1/4 times 8. Or, if we go the other way, if I have like 5 times 7 plus 5 times 3, I could say that's the same thing as 5 times 7 plus 3. So distributive property can go both ways. You can put a number into a set of parentheses, or we can add a set of parentheses to the problem using this distributive property. Identities, the additive identity, so the identity for addition is different than the identity for multiplication. So identity for addition is 0, what's called the additive identity. So what number do I add to another number to get the original number back? So we add 0. And the multiplicative identity is 1. So 15 times 1 is 15. Gives me the same number back. And the last property is the inverse property. So the additive inverse of a number is its opposite. So if I add the opposite of 11, I get 0. And the multiplicative inverse of a number is its reciprocal. So 8 times 1/8 equals 1. So looking at identities, we notice that how we get 0. 0 is the additive identity, and 0 is also the sum when we add inverses. 1 is the multiplicative identity, and 1 is the product when we multiply inverses. So there's some connections there. So we're going to use these properties to rewrite some of these problems, see if we can make that math easier to do in your heads. So kind of changing the problem up, say, oh, I think it'd be easier to do this, and then change that. So I see a 3 with both the 6 and the 4, so what I'm going to do is use the distributive property and say, well, that's 3 times 6 plus 4. And then I can finish that, so that's 3 times 10, and that's 30. So using the distributive property there, I see 5 plus 8 plus negative 8, so I'm going to use the associative property to say, well, that's 5 plus 8 plus negative 8. And then the inverse property of addition tells me that negative 8 plus 8 is 0. So that's the inverse property. And then, of course, 5 plus 0 is 5. What I see here, 4/7 times 2/3 times 7/4. So what I notice is that the 4/7 and the 7/4 are reciprocals, and so I'd like them to be multiplied first. So I'm going to use the associative property to rewrite this as 2/3 times 4/7 times 7/4. That's the associative property. And then, of course, the inverse property tells me that 4/7 times 7/4 is 1. And then, of course, 2/3 times 1, that would be the identity property, which is just 2/3. I think I probably should have said that over here, too, that 5 plus 0 is using the identity property. Last one here, so I got 100 times 0.75 times negative 2.38. So I'm going to use the distributive property to get that 100 into those decimals, because that'll make those decimals go away. So that's going to be 100 times 0.75 plus 100 times negative 2.38. So that's the distributive property. And then, of course, 100 times 0.75 is 75, and 100 times 2.38 is 238, so that'd be negative 238. And then just adding those together, we get negative 163. I'm not using any other particular properties of addition or multiplication. So there's that first page of notes. Go on to the second page here. We're just going to do some evaluating. Evaluate is just another way you can think about evaluating is just that you should be plugging in when you're asked to evaluate. So they want us to evaluate y plus 3 over y minus 3 for 5. So I'm going to plug 5 in. It's always a good idea to, when you're plugging a number in, to put it in parentheses. And then we're going to use our order of operations to do this. So we should be simplifying the numerator. We should be simplifying the denominator before we try to do any division. So 5 plus 3, of course, is 8. And 5 minus 3, of course, is 2. And then we can do the division, which would give us 4. Seven minus 2t for negative 2, so 7 minus 2 for negative 2. So a couple different ways to think about this. You could think about this as 2 times negative 2, which would lead you to 7 minus 2 times negative 2, which would be negative 4. Or a different way to think about it would be to say negative 2 times negative 2, which would be positive 4. So that would be 7 plus 4. So, of course, subtracting a negative is the same thing as addition anyway, so you get the same answer, just different ways to think about it. You can't do both. I can't say it's minus and then use the negative, minus positive 4, which would be wrong. So I have to choose, is that a minus sign right now, or is it a negative sign? And just gotta kind of go with that. I prefer to do the negative in that case, just to get rid of it, because then I don't have to worry about subtraction more, and I like addition more than I like subtraction. So, of course, they're both 11. P squared q cubed for p of negative 2 and q of 3. So plugging in, I get parenthesis, negative 2 squared. So make sure that square's on the outside there. And then parenthesis again, 3. Close that, close the big set, and then we have a cubed. So going inside the parentheses, we need to be inside the big set, and then inside the little sets there aren't anything to do particularly. So then on the outside, so here, we need to square. Right? Of course, negative 2 squared doesn't mean, if you type in your calculator and negative 2 squared like that, it's going to give you the wrong answer, so don't be silly. You shouldn't be doing that in your calculator. You should know what negative 2 times negative 2 is. So still inside of our big set of parentheses, negative 2 times negative 2 is 4. Of course, 3 is just 3. Those are multiplying together. Cubed. 4 times 3 is 12 inside the parentheses, cubed, and then 12 cubed is a pretty big number, which is 1728. All right, last one of these, some fractions now. So I got 4m minus n times 5n minus m. So watch out with the order there. So I got 4, parenthesis, m is 2/3, minus n, which is 1/3. Ooh, close the big set. 5 bigs, so 1/3 minus 2/3. All right, so within the large sets of parentheses, we got some work to do. So I'm just going to leave the 4 where it is. Of course, 2/3 minus 1/3 is 1/3. And then minus 5. And then 1/3 minus 2/3 is negative 1/3. Of course, a whole number times a fraction. Remember, you just think about it, putting a 1 underneath the 4. So 4 times 1 is 4. 1 times 3 is 3. So it would be 4/3. Here, what I'm noticing is I have a minus and I have a negative. I'm going to think of those as two negatives. This is going to give me a positive product. And of course, 5 times 1/3 is 5/3. And 4/3 plus 5/3 is 9/3. Don't add the denominators. They just have to be the same. And then, of course, 9 divided by 3. Why don't I write it minus sign there? Is 3. So, all right, so some evaluation, some simplification. Getting those brains going. All right, here's a little word problem. So we have a photograph with length L and width W. So what they're talking about is, what's inside here. So they're saying this is L, that's W. Then we have, it's placed in the mat with a width of 8 centimeters, which they've indicated here. The area of the mat in square centimeters is to be found using this formula. So they've given us a formula for that. So what's the area of this mat? So we could use that area formula for any area of a mat that's, has the same width of the mat, whether it's 8 centimeters all around. The 16s are coming from, since there's an 8 here and an 8 here, there's the 16, and then an 8 here and an 8 here, there's 16. So that's where those are coming from. But this is really just an evaluation problem. Want to plug in L and W. So A equals L is 32 plus 16. W is 24 plus 16 minus L, which is 32, W, which is 24. So simplifying this in the right order would tell us to look inside the parentheses first. So, of course, 32 plus 16 is 48. And then 24 plus 16 is 40. And if I'm going to take it slow, then I would not have do 32 times 24 yet. And now it would be, there's no exponents, so I'd be in the multiplication stage. So I'd say, well, what's 40 times 48? And that turns out to be 1920. And then what's 32 times 24? And that turns out to be 768. And then what's those two numbers subtracted? Would be 1152. We are doing a word problem, so there should be a little word in our answer at least. And so we're talking about area, so we should be talking about square units. So I'm going to say that's centimeters, squared. So the area of the mat would be 1152 square centimeters. All right, getting to the end of it here. So just simplifying these. We're not solving or anything like that. Simplifying. So just using your order of operations when you're asked to simplify. Use your PEMDAS. Use your properties of addition and multiplication. So what I look at here, there's nothing to do inside the parentheses. There's no exponents. So first thing I'm going to do is distribute that -2. Again, I'm choosing to think of that as a -2. It's not going to be a minus -2, right? I got to make that decision. So that's 2/3 y, and then as that -2 distributes, you get negative. So 2 times 4/3 is 8/3. So -8/3, and then of course -2 times z would be -2z. The thing I should be looking for when I'm doing simplifying is combining like terms. So we got distribution, combining like terms. So I got 2/3 y and 8/3 y. 2/3 minus 8/3 is -6/3 y, and then minus 2z. And then -6 divided by 3 is -2. So I got -2y minus 2z. Since we have multiple variables here, usually just write them in alphabetical order. So it's going to stay put the way I had it there. I apologize for my handwriting. It's been a long time since I've used this, so hopefully it'll get better over the semester. No guarantees, though. So here, second one. So 5/t minus 2 minus 3/t plus 1. So what I'm seeing here is it'd be helpful to rewrite this so that kind of like terms are near each other. So using the commutative property. So that's going to allow me to say, well, that's the same thing as 5/t minus. I'm making sure I'm bringing this over, not because that's a minus. And it's because there's a minus in front of the 3/t. And then the -2 is now moving over, and then the +1. Of course, 5/t minus 3/t would be 2/t. And then -2 plus 1 would be -1. And since there's no other like terms there, I am done simplifying that. Okay, so let's look at this. I notice the parentheses, I need to do some distribution. So I'm going to start there. So distributing 4p, so that'd be 4pq. So again, just the idea of putting things in alphabetical order, minus 4p, as far as the multiple variables. I'm not going to say 4qp, I'm going to say 4pq, just kind of setting up a standard for myself to always put things in alphabetical order. And then as I look at this next distribution, distributing a positive q through here, so q times 1 is q, and then q times -p would be negative, and so go alphabetical, so -pq. And the reason to do that is because now as I look at these, I notice I have like terms, and sometimes if we don't take good care of writing things in alphabetical order, you might not notice that. If you write qp, you might not see that those are like terms. So just kind of setting up a standard for yourself to always do it a certain way. That way you'll notice things. So it's just a good practice. So 4pq minus pq would just be 3pqs. I have a -4p or -4p and then a positive q. So there's not really a set way to write something like this. I know that p is alphabetically in front of q, so I could leave it this way. Sometimes we take, the first one, the first letter in the alphabet, write it in front, and then the combination ones go in the middle, and then the next letter would go next. That's one way to write it. There's also kind of a convention in math that we don't like the first term to be negative if we can avoid it. So we got a couple things that are kind of going against each other as far as how you write your answer. I don't really care on something like this. It's not going to affect anything. So either one of these would be fine as far as how you write your answer. And then the last one here, so 9 minus s plus 2r plus 6 minus s. So looking at some distribution, so I have a -1 here, needs to be distributed through this, and then of course just a positive 1 here, which is going to distribute, which won't really do anything at all. But so 9r, so minus s, that's a -s, and then minus 2r. And like I said, the positive 6 isn't changing, and the -s isn't changing. Any like terms, so I notice I got some r's, I got some s's. If you want to sit there and rewrite it, you certainly can. I don't want to spend the time to do that. So 9r minus 2r, so that'd be 7 r's. -s minus s, so -1 minus 1 is -2 s's, and then of course the plus 6 just drops down. Again, multiple variables, it's hard to say exactly how to write it, but I would just, I have the r before the s, and then the constant term there is at the end, so with no variables. So I'll leave my answer like that. All right, last problem. If the amount p is deposited in an account paying simple interest r for time t, so there's a lot of variables here. P is an amount. I got simple interest r. I've got time t. The total value of the deposit a. Total value is given by, and so then they've given us a formula. So, oops. The amount equals the total amount equals the amount you've deposited plus that amount you deposited times the rate times time. So basically, like, how do you earn interest in like a bank account? Right? Whatever you put in plus the interest that you've earned. Rewrite the expression using the distributive property. So we saw that, and so remember the distributive property deals with parentheses. So here we know we don't have parentheses, so we're not going to be distributing. We're going to be putting parentheses back into it. And so basically what we're looking at is we see that those p's in both terms, I'm going to pull that p out of both terms. Essentially what we're doing right now is factoring. So, p times what is p? Well, that'd be p times 1. And then p times what is PRT? Well, that'd be RT. And that'd be plus RT since it's positive. So A equals P times 1 plus RT. That's the simple interest formula. So different way of thinking about it. So the assignment for this section is on page 15. And you'll find that on your PDF. What we're going to do is 3 through 67, every other odd. So you're going to see this notation throughout the semester, every other odd. Okay, so that'd be 3, not 5, but then 7, not 9, then 11, not 13, but then 15. Okay, so make sure you're skipping those middle odds. I know when I was doing the homework, I was accidentally forgetting sometimes and doing more than I needed to. So hopefully that goes well for you, and make sure you're asking questions if you're not understanding things. Have a good day.